So here we're going to be looking at parabolas, and this is kind of the third part of the survival video, being able to write the equation of a parabola. So to be able to do that with your calculator, you need to find 3 points on the parabola. And there's 2 ways that that will happen for you. The first way, part A, you're given a graph and you actually read the points off of it. So for instance, that's like this example. I can actually look on the graph and read exactly what the point values are. So I could say that's 5, 0, this is 0, 0, and another point in there might be 4, -4 or something. You can read it right off the graph. But the way that's more challenging, and that we'll often see it, is that you'll just be given a parabola, told that it looks like an arch or a bowl or something like that, and you've got to put in your own axes. So draw on your own scale and find the points. And what I mean by that is an XY grid, where you have y to the sky, x like that. Put in your own axes. So if you're given a shape with no axes, a couple ways you can do it is draw it right down the middle. Another way you can do it is draw it to one corner. This one I might put through here, so that the bottom touches the bottom one. So it's up to you. You'll look at the problem and decide which way to go about it, but really through the middle or off to one side will be fine. And this will capitalize on symmetry in parabolas, where we know that if I draw a line through the min or the max, the distance from the middle to one side and the distance to the other side are going to be the same. So you've got symmetry. You can fold them on half and they'll be the same thing. And there's another video on symmetry for parabolas, so if you're struggling with that idea and actually drawing on your own axes, that would probably be a helpful one to go back and watch again. But here we'll look at actually finding the equation with that. So I'm given a bunch of words, blah 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 blah, and we've got to read through them to figure out what's going on. So an arch is 16 meters tall. Oh, well that means this arch goes up to a height of 16, and the base is 20 meters wide. Oh, okay. So I'd say my base is 20 meters wide. Find an equation, or find the equation for the parabola that models this arch. So we're looking for a rule that I can use to model this arch. It's quite clearly a parabola by the shape of it. And what's not on there is any axes, so I can't read points. I can't tell you what anything is. So what you have to do is actually draw your own on there. So I'm going to draw in my y-axis from there, and my x-axis there. Once you have your axes in, you can start to actually read points. So this parabola goes through where my x and y axes meet. That point is going to be at 0, 0. I know that it's 20 meters wide, so over here there'll be another point that's 20 meters along, 20, 0. I've gone over 20, but I have not gone up. Please don't get them backwards, x, y. For the points. Now I need a third one, and that's going to come out of my vertex here, my maximum. I know that it's at a height of 16, but I need to know where it is in x. So I'm going to have something in 16 for it. And if I think about the parabola and the symmetry, it's a total of 20 across. And the top is exactly halfway through. So halfway through 20 is 10. I know that the maximum happens when x is equal to 10. So I now have 3 points for my parabola. So you'd use those 3 points, and we'll put them into stat using the x squared. So going into stat, put that over here. Stat, and my points are 0, 20, 10, and matching up the y's 0, 0, and 16. And stop and double check. Do those points actually make sense? X of 10, y of 16, x of 20, y of 0, 0, 0. Next step again, calc, graph 1, and this is a parabola, so I'm going to use x squared. So those are my numbers. A is equal to negative 0.16, and that goes in front of the x squared. B is 3.2, that goes in front of the x, and C is 0, so I don't need to write that. So my equation, as I write it out, by is equal to negative 0.16 x squared plus 3.2x, I think. Yep, 3.2x. I don't need to write the 0 at the end, and I'm noticing that my r squared is 1, so that's a good sign. I have probably a correct relationship. So that's my rule. And from there, you can go in and put it into your calculator, use gsolve, substitute, do all sorts of fun stuff with it. So again, draw in your own axes, find your own 3 points. Look at another example. A monument in the shape of a parabola, shown here, is 4 meters wide at the base. Okay, that means from there to there is 4 meters. At a height of 5 meters, the sides are 2.3 meters apart from each other. Okay, so at a height of 5 meters, that means I go up by 5. The distance between those 2 points is 2.3 meters. Tricky. So next thing I need to think about is I have to put in a scale. I have to drop in my axes here so that I can make up points to put in my calculator. And for me, since I don't know the max, I might actually draw my axes through the middle. Now it can work out if you put it on the edge, but it'll be a little bit more complicated. So here, I'm going to put my y-axis right through the middle and my x-axis along the bottom. And part of why I'm doing that is so I can kind of capitalize on the symmetry here. So let's come up with some points. Remember, for a parabola, you've got symmetry, so half of it comes before the max and the other half comes after that. So if it's 4 total across, what's half of 4? Have 2 on this side and 2 on this side. So my point here would be at -1, -2. So I'm going to have -2, comma 0. And over here, I'm going to have +1, +2, so 2, comma 0. Now, I don't know the max, but they did give me other information that at a height of 5, so a y of 5, I've got 2 more points here. And let's figure out what those would be. So the total distance between them is 2.3, but I know that I have to figure out how far that is if I split it in half. So from 0, how far in one direction, how far in the other direction. And what you would do is do 2.3 divided by 2. And you get 1.15. So again, 2.3 divided by 2 equals 1.15. So I know that I'm a distance of 1.15 in that direction and a distance of 1.15 in that direction. This being the positive numbers. So my x here would be 1.15, my y is 5. And over here, it would be negative 1.15, comma 5. So that's actually 4 points, but that's okay. We can use all 4 of them. Again, that's been using symmetry. I draw my axes down the middle, split it in half, and then I find out how far to either side. One will be positive, the other one will be negative. Going back to stat, put in some points here. So I have -2 and 0. I have 2 and 0. I also have -1.15 and 5, a height of 5. And I've got 1.15 and a height of 5. So I'm going to put all 4 points in there. Graph 1, calc, parabola, and there's my equation. So it's not pretty, but again, you can round. So I could do -1.87 and something like 7.47. So here I've got my a squared, so that times x squared. B I don't need because it's 0, can leave it out, and c is that number there. So if I'm to write out my equation, here I'm going to get y is equal to -1.87 x squared. You could say plus 0x if you need to, plus 7.47, but I would probably just write it without that 0. And again, that's from your numbers here. So for these parabola problems, you just have to put in your own axes, draw them in, use the symmetry to come up with the points that you need into stat, and you've got your rule. And from there you can solve pretty much anything.